This is for assignment number 11. Problem number 1 is regarding elasticity, and the equation for elasticity is this one. And in this problem, you are given the force, which is the load. You are given the area. You have to look it up, the number for steel, so you can look at table 10.1, and you know this, so from there you solve for that. Problem number 2, you have now two different diameters here, and you apply a force F here, and you know this distance D. So the stress is the same, the force is the same on this one that on this one, but the stress on this one is 4 times larger than the stress on this one. So this one extends, if this one extends delta x1 and this one extends delta x2, and D is the sum of these, delta x1 is 4 times delta x2 because A1 is half A area 2. Number 3 is a sewing machine, and number 3 and number 4 are connected. In simple harmonic motion, the maximum velocity is given by the angular frequency times the amplitude. So in the case of the sewing machine, you are given the amplitude and you are given a frequency f, and you have to remember that the angular frequency is 2 pi f. And on number 4, you are given the amplitude and you are given the period. So you have to remember that the period is 2 pi over omega. So let's keep going in here. Let's go to number 5. Number 5 is now simple harmonic motion again. I remind you that the angular frequency in simple harmonic motion is the square root of k over m. So if you want to determine k, that is m times omega squared. So in problem number 5, you are given the frequency, so you are given f, so you can calculate that, and you have m. And the equation, of course, is going to be the amplitude times cosine of omega t, and then you will have to input that number and input that number. Let's go over number 6. Number 6 is this is the solar power thing. So right here on Earth, per square meter, we have 1.2 kilowatts per square meter. That's why we can do solar power. Where that's come from very far away. This distance is D. This distance is 150 million kilometers. So double check that and be careful with the units, but this is the distance that is important. And so the power from the sun, is going to be the 1.2 kilowatt per square meter times, you see the power goes everywhere on the sun. So you are in a sphere at a distance d over there. So that area is 4 pi d squared. So when you take that power and you multiply by that area, you are going to get the power of the sun. I hope it's clear. Number 7, the wavelengths of a wave. So the wave, you have, this is the relation between the velocity, the wavelengths, and the frequency. And it's also that because the frequency is the inverse to the period. So if you have a speed and a period, then you can calculate directly the wavelengths. So let me go to number 8. Number 8 is What is the speed? Well, the speed is also lambda f, but that is 2 pi over k times omega over 2 pi, so the 2 pi cancels, so it's the same as omega over k. And since you have in the equation, you can solve directly with the numbers that they're giving you. Number 9 is just an inspection. You have to recognize what is the amplitude there is given to you, so you just put that number in there because the equation that is putting in there, this is the amplitude and sine of omega t minus kx. So the wavelength, you get it from 2 pi over k and so forth. So it should be straightforward. Number 10, well, one goes twice as fast as the other wave, so that travels half of the distance. The other one, so you are given half of the time, so you can calculate the total distance. So that should be also pretty easy, and we are going to stop it here.